Hello and welcome back. Okay, in the last VGA video, I designed a new backplane to connect together various submodules of the VGA subsystem once we've turned them into PCBs. And so today I want to take the first chunk and turn that into a PCB to fit in that backplane. Now I did get the PCB for the backplane, that came through okay. And so I'm not going to force you to watch me solder this up because it's all just a stack of through-hole componentry. But if you click on the link to my second channel, you'll be able to take a look at that. I've already published it. Okay, I'm particularly proud of this side-scrolling demo. It's got quite a nice 3D effect to it, and it shows the horizontal scrolling component. So here is the PCB for the first three modules. Now this basically lines up with 3 out of the 4 sections we've got on the breadboards for the VGA circuit here. So the interface though is kind of spread out a little bit. The sync generation is these top 2 boards here underneath the DAC and output stage. And then the tile map is kind of intermixed with the interface stuff spread down here, although we've referred to that as frame buffer so far, because that's kind of how we're using it in this introductory phase of the VGA circuit. Interface PCB would be logical to go first, but it kind of doesn't save us any breadboards at this point, so it doesn't create any space on the desk. The tile map, that's quite a big step, and we need a lot of this supporting circuitry to go with it. So I think the sync generator is going to be the simplest standalone circuit. So that's these 2 boards. We can maybe move the output DAC breadboard across, and that will give us a functioning system hopefully while we translate the rest of it into PCBs. So let's take a look at schematic and PCB design for the sync generator. Okay, so I've taken the footprint that we put onto the temporary backplane, lifted that out as its own little PCB as a starting point. So I've also got the connectors. But when we designed the VGA circuit, I did do this bit of schematic. So we can pull that straight in. Now this isn't quite everything, but it's quite a bit of it. Okay, so this 574 is gating the output. Okay, so I'm actually taking the reset line direct from sync data 6. No. Sync data 2. So haven't talked about that line yet, but I will get around to it at some point. Line clock. That's 1. Combined blanking is 3. H-sync is 7, V-sync is 6. Now we do need to bring all of these lines out and put them on the main bus on demand. So let's just number them all the unused ones. Now the horizontal and vertical blanking interval, we don't actually use these outputs apart from in the status readback. Now what's bad is in the breadboard version we actually use a 541 to drive this data onto the bus on demand, and that's actually not the right thing to do. Now we can use an output enable line from this 574 to issue the assert. Push that onto the main bus as we want, but we need a copy line. Now what I think we'll do is have that copy line as the inverse of the assert line, just so when we're asked to assert we latch the current data in, and that should be a safe-ish output. At least the outputs aren't going to be changing while we're asserting it onto the bus. But it does seem like overkill to bring a 74 HCT04 in just for one inverter. Let's see where we get with everything else. And of course we need a clock divider before we drive the sync clock. Okay, so we're going to take the sync clock out of Q3. So that's the divided down clock we want. This one, the master reset, we're just going to tie high. CET needs to be high as well. The other outputs are unused. But these data inputs, they will need to come down to ground as well. Okay, I need a 74HCT04. It's worth noting that there are actually chips with a single inverter on, but I don't have any, and I particularly try and avoid adding additional parts to the bill of materials. This does feel very wasteful though. I'm going to add something though. I think it would be nice to have a header that will give me access to all of these data lines, just for probing and testing. I imagine we're going to hit issues with the circuit later on where it will be very convenient to be able to just grab one of the sync signals on the scope. Unused input. I wish it would let us say that those warnings are okay and we know what we're doing. I know it says we're allowed to ignore that warning if we're sure we've done the right thing, but it's kind of sensible to get rid of all the net warnings. Hang on, that main bus is the wrong end. Normally do these right to left. Oh, it doesn't go anywhere else. We can keep that to ourselves. Fix these ones though. It would be a lot easier if I'd put this at the top. Okay, I have to worry about getting those main bus lines all the way up there, but this is actually going to be a much better way of doing it. Oh, this is annoying. The VCC and ground lines aren't connected up properly. It's annoying VCC and ground aren't on here at all. This symbol's useless. Got a vague memory of hitting that before. Now I know the pipeline stages had ROMs that worked. Now we could put this vertically actually. Yeah, that puts a lot more lines close to where it needs to be. One thing I will say about this circuit is these HCT163s, one of these needs to run at 25 megahertz, and that is right at the boundary of what the HCTs can do. So I am considering switching just for some of the counters to a different logic type. I think probably ACT, just to give a bit more clearance. I will use a socket for this, I think. It's a pretty reasonable layout though. Right, I'm going to socket this, so I'm going to put the capacitor in a slightly more central location. Okay, I think this is pretty good. I think it's going to be fairly cost effective to make this 4 layers, which is going to make life an awful lot easier for us. Now this can catch you out. You have to separately identify what the net is for the planes. So I once labelled this one VCC, but I hadn't changed this here. So I didn't actually have a VCC plane. Might have been an idea to think about more where these address lines are going to line up with the counter chips. I don't think it's that bad though. This one's kind of tricky. We should afford to put the main bus up the top because that would have made this much neater. Alright, I think that's all ground lines. Now this routing is going to work out okay, but it's pretty obvious that I could have arranged the components better. On some of the future boards, I don't think I'm going to have quite as much freedom. Okay, so let's get some ground planes in. Okay, I've got a good feeling about this PCB, which is probably a bad sign. Let's get that made. Right, let's take a look at this. These new PCB bags from JLC have the tabs to tear it open by hand. Significant reduction in my risk of cutting my hand open. Okay, these come out nice. Strange nibble out the sides of these. Always helps to give the PCBs a good clean. And I've also got a stencil. That was imperfect paste application. There's a couple of places where it's squeezed out a bit, but not to the degree it's going to cause a problem. Okay, so the crystal requires some special values, so I'm going to use my little book. So these are 10 nanofarads. I've used a few of these of late, so I might actually have to buy some. Compared to many of the recent PCBs, the component count on this one is quite low. This is that same thing we hit the other day, where the footprint is not perfect. These are actually ACT rather than HCT. And that's partially because when I went to order them, the HCT were out of stock. But I was planning to make this one up here an ACT because they do handle speed a bit better. And I'm thinking of using ACTs on anything that actually touches the 25 megahertz component. They're all pin compatible and very similar specifications. They're TTL compatible lines. They're just a bit faster. And I've had a couple of issues on the breadboards, which I suspect are the propagation delays on the HCT components or VLS components not being quite fast enough. 25 megahertz is right at the top of what the HCT components are capable of handling. In fact, I think I'm using some of them slightly out of spec. There's something about this one I don't like. The pins aren't well aligned and it never quite pulled into place. Now, I've always used sockets for crystals before, but I really don't want any possible sources of issues. So let's actually solder this one in. I think that's a really nice little board. Need a way of testing this. Obviously it requires the synchron. how are we going to test this? Okay, first up, if we plug it into this back plane, we get easier connection to all its various terminals. Not quite sure how I bent that. Okay, so now I don't think there are very many inputs to this, but we do need to make sure we haven't messed anything up. I think the primary issues are the device lines down here. So I've got power and ground coming in. Now we don't use the load line, but we do use the assert line, and we don't want to leave that floating. Let's take it high with a power line there. Okay, I think this should actually run. So we can pick up ground there. Now the VGA clock should be coming out there. 25.175 megahertz. So that's a good sign. Also a ground line there. And then vertical sync should be there. Okay, so that's 59.94 hertz. That's very promising. All right, let's grab another ground. Okay, so that should be horizontal sync. A little bit of bounce there. And here the purple trace should be the blanking interval. So it's a nice little regular bit, each scan line, and then a big chunk near the vertical retrace. Okay, that kind of feels all right. Okay, so as much as I'm able to establish, I think this is working. So the only real choice I've got now is to try and wire it back into the build and see if we can actually make it do something useful and drive the screen. Now that's going to look pretty nice there, if only we can make it work. Just going to sit it on top of the register stack for now. Right, so these are the two boards that are coming out. We want to keep the output stage, keep all of this tile map and interfacing logic, and work out how to make the connections down that are going to keep it working and the connections up. So let's start with up. This is easy. That's the device control line. That can connect straight into the bottom there. Probably need a shorter wire for this, but that's going to do the job. Shouldn't need that anymore. So that's the direct correlation between this chip and I think this was a line driver we used here. Yeah, we use a latch here just to improve the synchronization. We can grab the main bus connection. Now in theory, the sync generator should actually power up now, and it will deliver timing information, so we could use it to drive the audio system. So that's kind of cool. But we do need to back connect it into this board. Right, so that's a clock line. I can pick that up from the VGA signal when we get there. That's blanking, and that'll be horizontal and vertical sync. Right, so it's blanking connected back. Horizontal and vertical sync. Right, so top pin, that's horizontal sync. Next one across, that's vertical sync. Let's do that first. Now we've got 1, 2, 3, 4 wires coming downwards, and we need to remind ourselves what they are. Well, that's the clock at full speed. pick that up off the interface board, I think. May need to go elsewhere for that when we actually do the interface PCB. Actually, we can use this header here to make easy connections for temporary patching. So that's the horizontal sync. Then we got bit 1, that's the line clock. Vertical sync, that's resetting our mode of operation in this flip-flop. That's a bit of functionality I want to talk about in the future actually. Let's just ground tie. Is that everything? That's a ground line, may as well use it for now. Okay, so now I'm going to try and extract these two breadboards, and that's a problem. Get these caps back in, they do help at the high frequencies. Need some power over here. And now I get to find out what type of video this is going to be. I think everything's there. Okay, so need to load some code up. Okay, so I'm going to use a slightly different piece of test code here, and it's not working. No, I just stored the processor. Yes! Okay, this is actually awesome. I do need to stop sounding quite so surprised when things work first time, but that's two breadboards that have been transferred to the PCB, but actually a lot of what I do with the VGA circuit that isn't VGA, like timing for the audio system, I don't even need these breadboards anymore. That's going to make my life a lot better. But hopefully the stabilization of this, because some of these lines are getting a little bit flaky, that's going to be pretty good. I think probably the interface is what we'll convert next. That's mostly just controlling the lines that say when we're accessing particular memory regions and particular registers. So that's going to make life a little bit easier just in terms of simplifying some of the extra lines we've got going around here. But this is great. Okay, it's really rewarding when a piece of work like that actually works first time. So that felt good. Okay, so I am conscious that in the VGA series, we haven't added any new functionality for a few videos, but I assure you that's coming, and I hope you appreciate that that doing this conversion work to PCBs is what's going to open up the production for being able to extend the circuitry a bit. Okay, I hope you found this one interesting. Thanks a lot for watching, and I'll see you again soon. Goodbye.